Thanks for tuning in to the Oxygen Alliance YouTube channel, where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell. Thank you for joining us for week 18 of the Oxygen Concentrator Talk, brought to you by the Oxygen Alliance. You're with me, Mwai Lungu, and I'm currently in Lilongwe, Malawi. Joining me is my colleague, Timothy Mtonga, who is also joining in from Lilongwe, Malawi, along with our technicians from Open02 and Sunrise. So on the technicians panel today, we have Paulina Mohosho, who is joining us from Johannesburg, South Africa. We have Kowinda Singh, who is joining us from Chandigarh, India. We also have Cynthia Chikomoni, Linda Mishoni, Mteto Sinjani, and Aubrey Chinkunda also joining us from Lilongwe, Malawi. So for those of you that may not be aware, the Concentrator Talk is a virtual meeting that the Oxygen Alliance hosts every Thursday from 2 to 3 p.m. Central African Time, where we discuss the different aspects of oxygen concentrator assessment, use, and maintenance. So we always encourage you to send us questions of the different problems that you might be facing, and our technicians will do their best to respond to them. In case you have a question that you'd like to ask as we go along with the session, you are free to raise your hand, or you can just come off mute and then ask the question. We also encourage you to keep your microphones muted and your videos turned off, just to conserve the bandwidth for everyone else. So just like we did last week, before we jump onto our questions, I would like to just hear from everyone else. If you can please share with us the project that you've been working on, maybe some of the challenges that you have faced, that would be great. So I'll leave it open to anyone to share with us the things that you've been working on during the week.
All right. Hello, everyone. So I guess I'll just start. I'm Francis Sambani, and I'm a team leader for the Open02. And so we usually do go to the fields from time to time to try to repair oxygen concentrators in various district hospitals around the country, which is Malawi. So right now, we are in Chikwawa in the southern region of Malawi. And here we are training and also fixing oxygen concentrators. So the training actually is focused on the engineers and the technicians in the maintenance workshop. So that is what we've been doing all along this week. And so the training, we try to divide it into 3 parts. The first part is just like the theory, so whereby we tell them basically we tell them how an oxygen concentrator works, so we explain that, but mainly we focus on the troubleshooting process, like how they can troubleshoot different problems in an oxygen concentrator. So for example, maybe let me just give a brief example of a valve block, like how they can troubleshoot a valve block, like if they assume that a valve block is faulty, they can either check the resistance of the valves if it's a solenoid valve, and also check if the valve itself is receiving voltage, or maybe if the wires are broken or damaged. So that would be like a basic example of how they can troubleshoot. So that is like the theory part, and then after the theory part, we have the shadowing session, whereby we work along with the technicians and engineers. So yeah, so I think that like betters up the process of them learning on how they can fix the oxygen concentrators. And the third part, which is the last part, is whereby the hands-on session, whereby we let them themselves fix the concentrators while we give them a hand. So those are like the 3 parts. And mostly, as I can say, on the challenges part, maybe the challenges have been like the challenges haven't been like, to my side, I can say the challenges have been let's say, for example, I've been called like to several nurses by several nurses, saying that this concentrator, you fixed it, but then it's not working. It's bringing in low oxygen, and these have been the dual flow oxygen concentrators, whereby you go there and then you find out that they've opened both flow meters. So basically, we just tell them that, oh, you're not supposed to go above 8 liters on these concentrators. That is added cumulative flow. Like if you open this flow meter, don't go past 4 liters. Or you can go past 4 liters, maybe you can go to 6, but then on the other flow meters, on the other flow meter, you can go past 2. As in, if you add the 2 liters, the 2 flows, they shouldn't be past 8 liters per minute if it's an 8 liter dual flow oxygen concentrator. So that is like the main challenge that I've faced this side. And thank you.
Thank you very much, Francis, for that update, all the way from Chikwawa. So in the interest of time, if we also have some updates from the other members on the call, I would advise you to just paste your update in the chat, and then everyone else can read it from there. All right, now to jump on to our questions of the day. So our first question says, I am a technician at one of the district hospitals in Malawi. I was working on DevilBiss 515 that was bringing a need service alarm. I changed the sieve beds and serviced the compressor. The purity went up to 95%, but after running for some time, the service alarm came back. How can I solve this problem? So I will ask Kuwinda to take this one up.
Thanks, Mavi. So the DevilBiss 515 oxygen concentrator is having a sensor mounted on the control board, which measures both the purity and the pressure, as we can see on the graphics mounted there. So it measures both purity and the pressure. Since you have just replaced the zeolite, you can just use an oxygen analyzer just to verify that is it producing high purity of oxygen. One other issue here could be that the oxygen concentrator is not producing enough pressure. So make sure that you check the pressure being produced by the compressor, just to be sure that it is producing the expected pressure. If both the pressure and purity are fine, then that might indicate that you have an issue with the oxygen sensor on the control board. To be sure if the problem is really the sensor, replace the control board with another board of the same concentrator model, which you know is working properly. If it is available at your facility, to see if the alarm will stop. On the DevilBiss 515 concentrator, the oxygen sensor is shouldered on the control board, so you cannot easily remove the sensor and place it on the another machine. The easiest way is to get functional board and use it for testing. If the sensor from the other control board performs without any issues, then you might need to either replace the sensor if you have a that control board that you can change from, or you might need to just replace the whole control board. Thank you, Mark.
Thank you very much, Kuwinda, for that explanation. I hope that was clear. But in case we have some questions from the audience, you are free to ask. You can just unmute your mic and then ask the question. So we have a poll at the end of this question. So Teto, if you would please launch that one up.
All right, thanks, Maui. So I'm gonna launch the first poll now. So it's actually saying that, can you identify an oxygen sensor on a DevilBiss 515 concentrator? So Maui, do you want to remind or just share with people where they can find the poll?
Yeah, sure. So if you are joining us from your computer, just go to the bottom right of your screen. The icon on the far right is the activities button. So if you click on that, it brings up a menu window where pause is one of the options listed. If you are joining us using a mobile phone, then click on the menus option, and that will open up a window where you have the activities button listed. So if you click on the activities button from there, it should be able to take you to another window where you have the pause menu as one of the listed options.
All right. Thanks, Maui. So the results are in. So it seems like everyone can identify the oxygen sensor on this model of a concentrator. Thank you.
Great. Thank you very much, Tato. So moving on with our questions. So our next question says, I was reading through the user manual of an Invacare oxygen concentrator. I came across a warning that advised one not to use the oxygen concentrator close to equipment that produce harmful radio frequency interference, such as speakers, MRI, or CTs. I wanted to know how exactly an oxygen concentrator may be affected by the radio frequencies. So Cynthia, if you would please answer this one.
Thank you, Maui. So radio frequency interference is also referred to as electromagnetic interference and is used to describe any effects that disturb electrical circuits by a way of induction or radiation. Electromagnetic interference can cause electronics to operate poorly, malfunction, and or it can stop the oxygen concentrator from working. An example is when you place a cell phone near a powerful audio equipment or speakers. It can cause noise or a series of beepings. In an oxygen concentrator, equipment that produce harmful radio frequency interference, such as the speakers or MRI, may damage the integrated circuits on the PCB through induction or radiation. There is no shielding for these harmful radio frequency interference on oxygen concentrators, so keeping the oxygen concentrator away from such equipment is necessary in taking care of our concentrators. Thank you.
Thank you very much, Cynthia, for that explanation. So if we have some questions from the audience, you are free to ask, or if we have some additional comments from the other technicians, you're also free to add on to what Cynthia has just explained to us. So we also prepared another poll at the end of this question. So Tato, if you would please launch that one up as well.
Yeah, sure. Let me do that. So our next poll says, did you know that oxygen concentrators may be affected by radio frequency interference? So give it like a couple of seconds so that people can vote.
So as we wait for the results, in case you are joining us for the first time, we also encourage you to share your email address with us so that we can add you to our mailing list, and that will enable us to be sending you updates from the Oxygen Alliance and reminders for the Concentrator Talk course. So just paste it in the chat and then we'll add you to our mailing list.
Yeah, so the results are in. So it's actually in favor of no. So I have 5 no's and 1 yes. So it seems like not a lot of people have, they knew about this actually, yeah.
Okay, so I guess it was great that someone brought that question up. All right, so moving on along with our questions. So our next question says, I am a biomedical technician at a certain clinic in Malawi. I was conducting preventative maintenance on an AirSafe Elite oxygen concentrator. This concentrator was producing a purity of 89%, but its sieve beds had been refilled with new zeolite the previous week, and the compressor was serviced too. I removed the covers to check for leakages and found that there was a leakage on the tube that is connected to the input of the product tank. I was removing the tubing from the product tank when the tubing I was removing the tubing from the tip of the tank where the tubing was connected broke. Unfortunately, we do not have spare product tanks of this type in the workshop. Can I replace the product tank with the one from another model of concentrator, for instance, the DevilBiss 525? So, Paulina, if you would please answer this one.
Thank you, Mwabi. The answer to this question is no. You cannot replace an SF Elite concentrator product tank with a tank from another concentrator model. And there are several reasons why this should not be done. Firstly, product tanks from different concentrator models differ in size and in pressure. For instance, a product tank from a DevilBiss 525 is bigger than that of an SF Elite. Therefore, if you were to use a DevilBiss tank on an SF, the output pressure of the machine will decrease due to a higher volume of the bigger tank, and the result of this may be low purity. Secondly, concentrators are designed in a different way to accommodate the parts that come with that concentrator model. Thus, there will not be enough space in the SF Elite concentrator to accommodate a product tank that is bigger. Lastly, and a very important reason to take note of, is that the product tank of an SF Elite contains zeolite, which helps in further purification of the oxygen coming from the sieve beds. And it also helps in stabilizing the oxygen in the product tank. So it is always best to replace the tank with one from the same concentrator model. So if the concentrator you are working on now is needed urgently, you can use an epoxy to join back the broken tip to the product tank. You should ensure that there are no leakages when you put the tank back into the concentrator, and that is after the epoxy has dried. Thank you, Mwabi.
Thank you very much, Paulina, for that explanation. I hope that was clear. And if we have some questions from the audience, you, as usual, you are free to ask. And if we have some additional comments from the other technicians, you are also free to ask. All right, seems we do not have a question. So we also have another poll at the end of this question. So Tato, if you would please launch that one up as well.
All right, I have launched the other poll. So it's basically asking that, have you ever encountered a problem with a product tank of an oxygen of any concentrator model? So I'll give you like some seconds so that people can vote. I mean, another problem that we face with product tanks is like even finding water inside the product tank as well. All right, so it seems like I have 4 yeses and 1 no. Thanks, Maui.
Thank you very much, Tato. So moving on along with our questions. So our next question says, I am a biomedical engineer working at a certain hospital. I was working on an AirSep New Life intensity. Upon assessing the concentrator, I found everything working perfectly except for the 4-way valve. The solenoid valve seems to be underperforming when wasting. I tried to use the voltage to check the voltage. All were giving out 198 VTC with the internal resistance of 3.2 kilo ohms. But still the solenoid valve seemed to be 40. specifically the wasting part. What could be the problem and how can I solve that? So I will ask Aubrey to take this one up.
Thank you very much, Maui. So having measured the voltage and resistance and nothing changed, the next thing to do is to disassemble the valve block and clean all the airflow passages. As time goes with the continued pressurization and depressurization of the sieve beds, the zeolite keeps rubbing against each other in the process, especially if the zeolite wasn't nicely compacted. And this leads to the formation of dust within the sieve beds. Some of these dust particles make their way out of the sieve beds. Since they have to go through the valve block, the particles begin to accumulate in the valve block, and this causes a blockage in the system. This results in narrowing of air passages, which causes the concentrator to suffocate during the purging process. In order to solve this problem, you need to clean the solenoid valve pathways, which requires that you remove the valves for you to do this successfully, as you can see in the picture that is shown. Remove all the solenoid valve coils and the exhaust muffler from the manifold. This will help you to access the passage for cleaning. Clean the pipes thoroughly so that you no longer have blockages within the air pathways. After cleaning the manifold, reassemble the valve block, and if everything has been thoroughly cleaned, your valve block will come back to normal operating conditions. Even though you suspect that the problem could be with the solenoid valve, the other problem could be that the exhaust muffler must have been blocked. As I pointed out earlier, when the sieve bed is purging, some dust from the zeolite escapes as it begins to accumulate in the exhaust muffler. With time, if you do not clean the exhaust muffler regularly, the zeolite particles will accumulate in the muffler, and this will also cause your concentrator to suffocate during purging. If cleaning the solenoid valve does not work, then try cleaning the exhaust muffler. Thank you very much.
Thank you very much, Aubrey, for that explanation. I hope that was clear. But if we have some questions or comments that we would like to add on, we are free to do so. All right, so it seems we do not have any questions there. So moving on along with our questions, our next question says, I am a biomedical technician intern at a certain clinic. Last week, a certain nurse brought to the workshop an ASAP intensity concentrator to be serviced. When I switched on the concentrator and ran it for some time, I noticed that the low purity or high pressure LED was on the whole time, but there was no sound of the buzzer. Can someone explain to me why this was happening and what should I do? So I'll ask Linda to take this one up.
Thank you, Maui. So for ASAP intensity, be it 10 liters or 8 liters, it is equipped with an alarm system which is powered by a 9-volt battery, and the buzzer sounds continuously when there is power failure and periodically whenever there is high pressure or low oxygen purity. So whenever the buzzer is activated, there is need for an orange LED to be activated on the concentrator. So in your case, the buzzer may not be activated due to a number of causes. And one of these causes is a drained battery that powers the buzzer. Usually when the battery is in good condition, immediately after you have switched on the unit, the buzzer sounds for approximately 5 seconds. And if this did not occur, just know that the battery is drained. And you can also verify if the battery is drained by using a voltmeter to check the voltage being produced by the battery. So to measure the voltage, you have to remove the battery from the concentrator and press the voltmeters that probe on the positive terminal of the battery and the black probe on the negative terminal of the battery. And you should observe the reading of the voltmeter on the display. It shouldn't be below 9 volts. Another cause could be loose connections between the battery and the buzzer. So you have to check the wires that connect the battery terminals and the buzzer and make sure that they are securely fastened, and also ensure that there is no rusting on the terminals of the battery. And if you found out that the battery is drained, you have to replace it with a new battery. And also make sure that when pressing the new battery, there shouldn't be loose connections. And also ensure that you notice, you maintain the proper polarity of the battery and the connectors. And sometimes when the battery has drained and stays for a long time in the concentrator, it begins to release some chemical fluid that causes the connectors on the battery to form rust. If this happens, make sure that you clean the battery terminals before replacing the battery. And if you still don't get the buzzer working, that will indicate that the buzzer is damaged and should replace it with a new one. So you can see the an image of the buzzer and the battery in the graphics as displayed. Thank you, Maui.
Thank you very much, Linda, for that explanation. I hope that was clear. But in case we have some questions from the audience, again, you are welcome to ask. So moving on with our questions, our next question says, I'm a biomedical engineer at a certain district hospital. I've been working on a 515 DevilBiss. I switched it on and I measured the purity and pressure. When I closed the patient output with my finger, the flow meter board didn't drop to 0, and I could hear oxygen escaping. After performing a leakage test, I discovered that the final bacteria filter is cracked. I do not have a new final bacteria filter to replace it with. Can the concentrator function properly without it? So I'll ask Cynthia to take this one up.
Thank you, Mari. So 515 oxygen concentrator uses two types of bacteria filter. There is intake bacteria filter and a final bacteria filter, as shown in the diagram in the picture. That's the bacteria filter. So these filters in the concentrator protect patients from viruses and bacteria that are present in the air around us. The filter does not allow these bacteria to pass through to the patient. So to answer your question, the concentrator will function properly, but it is unhealthy for the patient to use that concentrator. I would advise you to purchase a new bacteria filter that you can replace it with. Thank you, Mari.
Thank you very much, Cynthia, for that explanation. So I see we have some comments from Michael in the chat. Sorry, I missed them. So you are asking, is it safe to say that a faulty control board can also be the cause of the solenoid valve not performing as expected? Linda, oh, was this question taken by Linda or Aubrey? I think that was Aubrey. Would you like to make a comment on that? So he's asking if it's safe to say that the control board also can be the cause of the solenoid valve not performing as expected.
Yes, that is true. The control board can also be the cause of the solenoid valve not working, because the control board also sends electrical signals to the solenoid valve. So if you have a faulty control board, the solenoid valve might also not work. So it's always advisable to also check the control board if it is fully functional. Thank you.
I see we have a hand from Tato. You have something to add on?
Yeah, so I just wanted to clarify that it's actually like the voltage, not necessarily signal, but the voltage. So if you take your multimeter and put it into voltage mode and take the two leads, insert them where the wires are coming from the control board going to the solenoid valve, you should be able to get voltage readings there, like 200 volts if it's ASL. Yeah, thanks.
Great, thank you very much, Tato. So he also made another comment about the air-sep. So he says, for how long was the LED on after it was switched on? So unfortunately for this one, it wasn't indicated, but as it is stipulated in the manual, normally the LED will stay on soon after you switch on the concentrator, and as the machine runs, it will turn off after the machine has run for something around 2 minutes. That is if the purity has reached the recommended level, which is around 84%. But if your machine is producing low oxygen purity, then the LED will still remain on. Michael, I hope that answered your comments on that question.
Yes, thank you.
Great. All right, so moving on, we will now take a slight diversion from our questions, as we normally do, and we will now jump on to our topic of interest of the day. So today we'll be picking up from where we left from last week. So last week we started talking about sieve bed refilling, and Tato presented to us the first part, and today he will be continuing with the second part of the sieve bed refilling process. So over to you, Tato.
Thank you, Maui. So I see time is not on our side very much. So I'll try as much as possible to go through the topic quickly. So last week, Concentrator Talk, we had the topic of interest where we're talking about the sieve bed refilling process. So I actually mentioned about that the process of refilling sieve beds starts from opening the sieve bed, cleaning, refilling, up to like so refilling, closing, and up to like pressure testing them. So I also had to explain in detail what you need to do before opening the sieve beds, which include like checking the humidity and all that, and also when opening the sieve beds as well as cleaning them. So this was like considered as part one. So if you missed part one of the topic of interest, you can go back and watch the last week's talk on our YouTube channel, Oxygen Alliance. So we stopped on the last talk. We stopped on cleaning the bed. So after like cleaning the bed, the next step is to actually refill the sieve bed. So the following are like the things you need to look into when you are refilling the sieve bed with zeolite. So the first thing you need to put into consideration is the zeolite combination. So you need to pay attention to the model of the concentrator because some might require just one type of zeolite. So we know that there's like the lithium-based zeolite and the sodium-based zeolite. So we need to pay attention to that. And some actually use a combination of both the lithium and the sodium-based zeolite in different levels. So I'll just give you an example. So it is said or believed that for a DevilBiss 525, some like the newer models, they actually use like 10% of sodium-based zeolite, and then this is placed at the bottom of the sieve bed. Its job is to actually more like absorb the moisture. And then there's like 90% of lithium-based zeolite at the top of the sieve bed. So this is more of like trying to get the best purity out of the sieve bed. So we know that lithium actually performs better as compared to sodium. Yeah. So that's like basically about the combination, the zeolite combination. Now I'll talk about the methods of refilling the zeolite in the sieve bed. So it is important to know that when refilling the zeolite, it is supposed to be compacted, meaning leaving no space within the granules. And this is so because you want the compressed air passing through not to take the dead space fluid, reducing the amount of nitrogen being separated. So I'll give you a good example. If you try and if you open the sieve bed and remove the zeolite and try just putting it back, you'll find out that you are going to have some remaining zeolite in your container while the sieve bed is like filled to the top. Why? Because by just doing that, the zeolite is not compacted, and you won't be able to put all the zeolite inside. So this being said, this leads us to some techniques that have been proven to actually compact the zeolite when refilling. So if you could go to the next slide. So the first one is the snowfall method. So this is like basically the process where the recap. So this one is the first method is known as the snowfall refilling or filling method. So snowfall is a process, like the snowfall filling is a process, but then you need to develop a tool. So the snowfall tool is made up of a funnel and a mesh that allows the zeolite to pass through. This is a very cheap technique, and the theory behind it is that the mesh randomizes the flow of the granules, ensuring each adsorption granule has a minimum energy and is able to find an optimum position within the sieve bed. So it stays like without leaving any spaces. So during this process, the sieve bed needs to remain flat, like needs to be 90 degrees to the ground, and it has to be still because if you tilt it, the zeolite won't sit properly. Yeah. So that being said, this method is actually slower and requires so much patience, and it has like some much more control in it. To the next slide. So the second method is using the concrete vibrator. So a concrete vibrator, for those who don't know it, is a machine used for construction-based purposes. So its job is to actually remove air bubbles within the concrete. So when you mix up the concrete and you pull it on wherever you're building, it actually leaves some air spaces, like some bubbles. So you use this to break the bubbles. So actually that functionality enables us to remove some air spaces within the zeolite granules. So as you can see in the graphics there, that's the poker or the concrete vibrator on the left side. So this tool is actually expensive as compared to developing a snowfall tool, and it also requires power to operate. So the only advantage, like the biggest advantage, is that it's very fast. All you need to do is you need to attach it to the side of the bed while the bed is also sitting flat, and then vibrate the bed. You then see like the zeolite dropping down. So all you need to do is to just keep on feeding the zeolite so until you reach the mark. So remember that before we pull out the zeolite from the sieve bed, we need to mark the end point. That will allow us that when you're refilling next time, we know where the maximum level is. Yeah, on to the next slide. So these are like the two known methods that we have actually used before, and they work for us in actually like Sunlight as well as OpenO2. Anyways, so moving on to the next step after refilling, and then we close the sieve bed. So I just wanted to list out this. I also talked about this in the last talk. So it is important to talk about the parts of the sieve bed when opening as well as closing. So the sieve bed parts are actually put back in order. So we see the round rubber on the bottom. That is like for concentrators like DevilBiss 525. And some concentrators don't have, so you don't have to worry about that. So for this model of DevilBiss, all you need to do is you need to, after putting the zeolite, you need to first insert that rubber and then take the filter paper. That filter paper has to be attached to the disc so that the filter paper is secured and it's been held in place. And then after that, we insert the spring on top of the disc itself. So another functionality of that disc is that it allows air to pass through. As you can see, it has some holes, and it also holds the filter paper intact. And then it also keeps the zeolite compacted. Yeah. So after putting in the spring and then we put the cap. So the cap has an O-ring that is inserted in its groove. So if you were to turn around the cap, you will see that there's a groove. So you need to insert the O-ring in there onto the next slide. So this being said, depending on the models of the beds you're working on, the closing of the sieve bed is different, just as opening the sieve bed. So I'm going to start with the one on the left. So the sieve bed with a nut, this is more like air-safe sieve beds. This one, all you need is to use your hands and push the cap downwards, and then you can put back the nut that goes on top on the threaded rod that appeared on top of the cap. So you need to keep in mind that for this model of air-safe, it's actually better you put in a washer that has like some seal in it, because the moment you remove the nut, you actually break the seal within the nut. So it's advisable that you put this washer that comes with like some rubber in it, and then it can actually create the seal. And the other sieve bed is the one with the screws. So for this one, you just have to also like push down the cap, and then you can screw down all the 4 screws and make sure it's sitting nicely. The other one is the sieve bed with a clip. So if you could go to the next slide. So for the sieve bed with a clip, you need to actually use something that can apply some good amount of force to compress the spring, because the spring of these models of concentrators like the DevilBiss 525, it's on the harder side. So this is a jig that was developed at OpenO2. This allows you to actually close these beds easily as compared to using different other types of clamps. Yeah. So for this one, all you need to do is you need to push the cap down and then just insert the clip. It goes inside its channel easily. Yeah. So just moving on and just talking about the final step. The final step is actually called pressure testing. So if we could go to the next slide. So we pressure test a sieve bed by hooking a pressure gauge on the air outlet of the sieve bed and attach a compressor on the inlet side of the sieve bed. There has to be a gate valve on the compressor side to control the amount of air going into the sieve bed, and a one-way valve to avoid unnecessary escaping of air from the bed during pressure testing. So we pressure test sieve beds at a good pressure value like 40 psi, because that actually simulates the output pressure from an oxygen concentrator compressor can produce. So filling in the bed with 40 psi should actually do the job. So after you have like put in the air inside the sieve bed, the next process is actually applying some soapy water foam around the sieve bed cup. So this will allow you to actually detect if there are any leaks. So, I mean, like some other leakages are so big that you can't even hear them. So using the soapy water will actually allow you to spot these tiny, tiny leaks. So normally when you apply some soapy water around the end of the sieve bed, it actually bubbles if there are any leakages. So maybe people might be wondering, like, what would be the causes of leaks when you just open a sieve bed, just refill the zeolite and close it? There are multiple things that can actually cause the sieve bed to leak. One of it is a damaged O-ring when opening or closing the sieve bed. So remember, the O-ring is soft. So sometimes when you're closing the sieve bed, you actually might damage the O-ring by just tearing it on the sides. So that can introduce some leakages. Another cause might be a tilted cup or a tilted end cup. So when closing the sieve bed, it's very tricky because the spring is always forcing you up. So sometimes if it's stuck on an angle, it means that that can create some leakages because the O-ring itself is also not sitting well. And another thing I think I already mentioned about it, it's more especially in an air sep where the model we close with a nut. So if you just open the sieve bed of an air sep and put in zeolite and just close it, it's gonna leak most of the times. Why? Because the seal is gone. So an alternative is using the head of the loof nails. It has like some rubber seal, so you can just put it in there. It works, and then you put in the nut. Or another way you could just find the right washer. Anyways, finally, another cause might be loose screws on the end cap. So for the end cap that has screws like for the Ox Pure, the J5, the long fade, if you do not actually fully close the cap by not tightening the screws, that allows the air to escape. Yeah. So that's basically about the process of refilling the sieve beds. People might think it's just opening the sieve bed and then putting in the zeolite and closing it, but it honestly doesn't work that way. You need to make sure that you do this in a very, like in a low humid place where it's like 45% and below, and then make sure that when you're putting in the zeolite, it's compacted and you pressure test, make sure there are no leaks, then you're good to go. Thank you so much, Maui. That's all about the topic of interest.
Thank you very much, Mteto, for that explanation. I enjoyed it. I hope everyone else did. So if we have some questions for Mteto, we are free to ask, or we can just paste them in the chat, and then he will answer all the questions that you might have regards to sieve bed refilling. So we'll just tackle one more question, and then we'll bring our session today to an end. So our last question of the day says, I am a biomedical technician at Namitete Health Center, and I am making a list of spare parts to be purchased. Among these spares are the pressure regulators. Can someone enlighten me on the factors that must be considered when choosing pressure regulators for different oxygen concentrators? So I will ask Aubrey to take this one up.
Thank you, Maui. So in relation to oxygen concentrators, a pressure regulator can be defined as a valve that controls the pressure of oxygen being released from the product tank by reducing the high input pressure from the sieve beds to a controlled lower output pressure. The pressure regulator also helps to stabilize the pressure of the oxygen from the product tank. There are several factors that one must consider when choosing the pressure regulators, and these factors include size, range of operating pressures, and the material of the pressure regulator. Pressure regulators are made from different types of materials such as brass, plastic, and aluminum, depending on the type of application and the environment that they would be used in. The pressure regulators are also mostly used. The pressure regulators that are mostly used in concentrator models are usually made of plastic, and on rare occasions, you may find some that are made from metal. The second factor which you must consider is the operating pressure range. Different pressure regulators have different operating pressure ranges. As such, you must check the types of regulators that are used in different concentrators and also check the data sheets to identify their operating pressure ranges. It is very crucial to ensure that the pressure regulator should be replaced by one of the same operating pressure range. Another factor that should be considered is to not all pressure regulators are designed to be used with oxygen gas. Thus, it is important to consider the type of application the regulator was designed to be used in. Some of the regulators are designed to be used with liquid, flammable, or toxic fluid. This is very important because some of the regulators have vent holes, and in oxygen concentrators, we do not want such types of regulators as they will affect the purity of the concentrator. Another factor that you must consider is the size of the pressure regulator. The different concentrator models have different product tanks with different port and thread sizes where the pressure regulators are mounted. Therefore, you must carefully consider this factor as well. In addition, size will also influence the choice of pressure regulators in a way that some concentrators have limited space where the regulator is mounted. So if you happen to purchase a pressure regulator which is large in size than the mounting space, you will have problems at the time you would want to place it in the concentrator. Thank you very much.
Thank you very much, Aubrey, for that explanation. I hope that was clear. So reaching this far, this now brings us to the end of our session today. And I would like to thank you all for joining us for the call today. Oh, I see we have a question from Michael. So he says, to mitigate water humidity getting into the sieve beds, is it safe to add descants like activated alumina before adding the zeolites into the canisters? Mteto, I guess this is your question since it's talking about sieve bed refilling.
For this one, honestly, I'm not very sure, unless maybe Mwawi, you know.
So in my knowledge, what I know is normally you just need to make sure that you have water separators. Like most concentrators that are being built now are coming with water separators. So once the air goes through the compressor, it has to go through a water separator before it gets fed into the sieve bed. So that helps to remove any water that you might be able to get in the sieve bed. So I haven't come across this method where they are adding some extra chemicals in order to mitigate the humidity. So that would be really great to know. Maybe Michael, if you can just explain more on that, that would be great.
Hi everyone. I have actually encountered, and after emptying the canisters, the desiccant, which is the activated alumina, is more of like chalk powder, is actually added at the bottom of the canister before you first of all fill it with the zeolites. And this only applies when the concentrator does not have a water trap, so that now the sieve beds are protected from the humidity. Thank you.
Thank you very much, Michael. Now that you have explained, that has reminded me of something. So there are some other sieve beds where they use a combination of lithium and sodium-based zeolite. So they normally put the sodium-based zeolites at the bottom of the sieve beds because the sodium zeolite has a higher affinity for water, so it easily absorbs the water. So they would normally put the sodium zeolite at the bottom, and then they fill the rest of the sieve bed with zeolite, which is something closer to, which is similar to what Michael has just explained to us. So thank you very much, Michael, for that input. All right, so looking at our time, we have now reached the hour mark, and this brings us to the end of our concentrator talk today. I would like to thank all of you for joining us today. Special thanks to Michael for your participation. It has been great. Just a reminder to all of us, I've seen that we have a couple of new joinees to the call today. If you could please paste your email address in the chat so that we can add you to our mailing list, so that we should be sending you the updates from the Oxygen Alliance and the reminders of the next Concentrator Talk call. We also have a YouTube channel where we upload all our recorded versions of the previous talk. So if you missed a couple of Concentrator talks in the past, you can just go to our YouTube channel, Oxygen Alliance, and you will be able to go through all the talks that we have held in the past. We also have a website, www.oxygenalliance.org. So if you want to learn more about the Oxygen Alliance, just go to our website and you will find all the information that you might need there. So reaching this far, I would like to wish you all a great week, and we'll see you again in our next talk. Bye, everyone.